Okay guys, welcome to your review folder over 6.12. I know there's some examples on the outside of your folder. As you can see, there's a couple of examples that are broken down word for you here. But what we wanted to do as well is before you start answering a few of these 10 questions provided, we wanted to go back and give you an additional resource so that you can kind of look through these things. So I'm going to do 2 examples with you to kind of help guide you through those examples before you do them on your own. But first, let's review a little bit of vocabulary. So when we have a box plot that looks like this, remember that line inside the box represents the median. And remember, the median is the middle number. So if you need to find the middle number, the first thing you need to do if they give you a set of data is put those numbers in order from least to greatest, or ascending order, increasing. All those mean least to greatest. And in order to do that, you need to go ahead and do that first and cross out the lowest, the highest, the second lowest, second highest, and go back and forth until you find the median. Remember, if there's 2 middle numbers, then you would find the average of those 2. Add those 2 numbers and divide it by 2 since you added 2. But remember, there's some important parts for this. Now, a lot of you guys get confused because you say, Miss Anderson, the median number, you said it was in the middle. But this line does not look like it's in the middle of the box. And remember the reason that is, it depends on your numbers here. They could be a little bit more spread out. So let's look. The first thing we want you guys to remember to do, anytime you have a box plot, get into the habit of labeling what these items mean. Because for an example, in this problem, I have no idea what my list of numbers are that they put in order from least to greatest to find this out. However, I do know that their smallest number is that very end point right there that's connected to the box. So its lowest point in this one is 40. I know its largest number in the value is the biggest value right there that's connected right there is 200. So I could easily find the overall range by subtracting those 2 numbers. Now again, that middle number, the median, is represented by that line in the box. So quartile 2, in this problem, we could already tell is right at 160. Quartile 2, remember, think about quarters. Half of a dollar is going to be 50 cents. So 50% of your data is always to the left of your median, and the other 50% of your data is always to the right of your median. Now, even though in this example, this looks really spread out compared to this over here, but stop and think about it. 160 is only 40 points away, or 40 pounds in this situation, from its maximum point. Where the lowest dog, the lowest weight for that dog was 40, that's really spread out from that median weight of 160 pounds. So this has more spread out. So we can even talk about that skew here in a minute. But let's keep going. Remember, we can also find what's called the inner quartile range. Well, range is the difference between your highest and lowest number, where inner quartile means between quartiles. So between quartile 3 and quartile 1. Remember, that's your left median. So after you find your median, you find the median of those numbers on the left. And your right median, the median of those numbers to the right of the median, is quartile 3. So I just wrote a little equation here. Quartile 3 minus quartile 1 gives you what's called the IQR, or inner quartile range. Again, a lot of vocabulary. We just want to make sure you're aware of on how to answer these. Now, clusters. Remember, this is where data or numbers seem to be gathered all around a certain group. Think about how you guys group up in the hallway. You all cluster around one thing, and that's where you're all clustered up. So give that stuff to you as a visual. Gaps are those spaces between clusters and outliers. That's where there's nothing happening there. There's a space between what's happening in the actual numbers itself. We'll look at an example here in a minute. And the last word we want to look at is outliers. This is for where your data points or numbers are very far away from everything else. Now, sometimes you'll have outliers and sometimes you won't. So let's just look real quick and answer just a couple of summative pieces, and we're just going to talk about it, and you can write it down if you want, but let's look and see what we know. Right here, this is the peak. That's your highest point. Now, it doesn't mean the highest point in value. It just means that in wait times between 20 and 29 minutes, that's where most people are waiting, and actually the frequency is 18. So this histogram, and we know it's a histogram because it's showing intervals, it's like a special kind of bar graph, shows the wait times in minutes for entering a concert. Describe the shape. So what's actually happening? And with that peak, we can draw our little tails. And remember, where the tail is the longest is where it's either going to be skewed left or skewed right, or we can say negative or positive skew. Now, what we mean by the tail is where is the data more spread out. And you can see that it takes me a longer distance to get here on this right-hand side, so we could say right skew, or some people might even say that's a positive skew, because it's on the positive sides on a horizontal number line or to the right. We can even say the peak is at not just a certain point, but at an interval of 20 to 29. And what that means with that histogram is at that peak, most of your numbers were in the 20s. Again, 18 of them were. Some other data we can see. Do we have any gaps? Let's look. Well, you got a lot of numbers right there, but look what's happening in between those intervals. Nothing's going on. So we could actually say there's a gap. The gaps are between 50 all the way up to 89, if you stop and think about it that way. Okay, let's look at some other information. We don't need to know this stuff because it's not a box plot. Clusters, let's see. There's clusters. Data's kind of around. Yeah, it's kind of a big group right there. And we have the gap. Outlier is that data away from everything else. And yep, hopefully you guys can see there's an outlier right there. So outlier at interval 90 to 99. So a lot of information that we know just based on looking at that histogram. Now real quick, let's look at this box plot too. We know the median, just getting some information. The median is quartile 2 is 160, and we know that that's pounds. Now you can't really tell that much with box plots. A lot of times you might not be able to tell about gaps and clusters, but you can definitely look and see outliers. And this little dot right here, this little asterisk, that's definitely my outlier because it's not connected to everything else. So we could say outlier is equal to 20 pounds. Okay, just a couple quick observations from that. Again, we can continue to go through this. Now you see that this is more spread out. So that would be that most of your data is spread out there. So that would be a negative skew or left skew. All right, hopefully that was helpful for you guys, and good luck on those questions.